Actually, yesterday to complete this one, but it's okay. That's in node of here, right? Classes, ABC, ranges, network and host portion, and subnet mask. If you have any doubt in that one, so again, just check it out. Next one is, here it is, AND gate. What is this AND gate? So there is logical gates are there. So maybe in your 10th class or intermediate, you've seen truth tables. Truth tables. So there is a logical gates. Means how our computer works based on a different logical gates only. So one of the gates is like a AND operation. Okay, logical formations. AND or not, XOR XNOR NAND NOR like that. Okay. So these are different logical gates are there. So logical means it defines a logical operation purpose. Okay. On off condition. It's very simple. See, it's on off conditions only. So this is contains a truth table. First we will discuss about a truth table here. So AND gate truth table is like if A is an input and B is an input, Y is an output, and A dot B is a function of this one. Okay. So if A is a 0 and B is a 0 and Y is 0, means if you are comparing two numbers, when you are doing with the two numbers, if both are zeros, output is 0 only. If A is 0, B is 1 and output is 0 only. Okay, A is 1, B is 0, output is 0 only. A is 1, B is 1, output is 1 only. This is like a multiplication operation kind of stuff. So this is your input and output like that. Okay. So we can draw a box in a word, right? So in a word, that for understanding this is enough. Later, I will do that. Okay. So this is truth table. So we need only one truth table, not required all other things. Okay. So understanding of this one, if both inputs are high, output is high. It means both inputs are 1, output is 1. If any one of the input is 0, output is 0. Any one of the input is 0, output is 0. Just an example, 1101. I take one number and I take another number, for example. So you want to do ending operation between it. So here if you are comparing these things, 1, 1, you get output is 1. Next one is 1, 0. Next one is 1, 0. Output is 0. Okay. And next one is 0, 0. Output is 0. 1, 1. You get a 1. Very good. Yeah. 1, 0, 0, 1. So this is my logical AND output. Okay. Always comparing with the two numbers. Otherwise you can do like a 0. If you put a 0, then obviously it is become 0. 1, 0, 0. 0, 1. Otherwise I will put a reverse order. So you will get a different output now. So 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 1. Like this, I got this output. I changed pattern to avoid another confusion. Okay. 1, 1, 0, 0. Yeah, I'll repeat. Same numbers I am taking here. So 1, 1, 0, 0. Okay, 1100 and 100 are taken like this. Okay, so first of all we have to compare each and one. You might put this one or a different one. You like this, right? Yeah, correct. See, look at here. This is 0, 1. Okay, this is 1, this is 0, 0, 1. You get a 0 only. 0, 0, 0. 1, 0, 0. 1, 1, 1. So each bit you have to compare from here to here, like this one, and this one, like this. Okay, each bit you have to compare one. So otherwise you can write very broadly like 0, 0, 1, 0, like this. So this one, according to the truth table, 0, 1, 0 only. Okay, 0, 0, 0, like this. 1, 0, 0 only. 1, 1, logically just 1. So this is the answer. See, everything bit to bit you have to compare. Bit to bit you have to compare. Compare means you have to A dot B type. Means 0 dot 0 into 1, 0 type. Okay, and truth table. Okay, so if in case the second one is all are zeros, what will happen? All are zeros. 0, 0. Sorry, you have to type from left, right. So, okay, you will take it from 1, 0, 0 only. 1, 0, 0 only. 0, 0, 0 only. 0, 0, 0 only. So, obviously, output, you don't need to think again. So, you have to check all zeros, then we have to put the zeros. Next one is I'm going to another number. For example, 1, 0, 1, 0. I'm giving another output input is 1, 1, 1, 1, like this. All at once. So, yes, very good. 1, 0, 1, 0. You will get it. Okay. So, how? 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 0. So, like this, you get a output. Okay. So, how it is thing is what I'm trying to explain with these two examples, with all zeros and ones, it means, you know, we know the tables, right? So very big tables, we know like 2 tables, 3 tables, 4 tables, 6 tables, 6 tables, like that. So if the very big version is there, I am going to ask 234 into 34 into 156 into 0. What is the result? Okay, so you have to multiply everything like this. Last you seen a 0 and you said, oh, it is a 0 last finally. Okay, so simply when you see a 0 thing, obviously answer is 0 without knowing how to multiply these big numbers also. Okay, so like this is the simple thing. Okay, so to prove that one point is, if one side of input is all are zeros, no need to think what are zeros on. And another hand is, if one side of input is all are ones, it repeats the same thing only. Mainly in AND operation, I'm not talking about any other operation. In AND operation, if input is something, but your one input, another input is all are ones, obviously you get same input. Like this is A, this is B, you get A only. Okay? A only. Okay? So very, very simple. Okay, it's a logically. So even if you calculate, if you take very big number and you are do ending operation with all ones, then obviously you get a same input only. Like A is an input, B is nothing but one only. Okay, B is nothing but one only. So obviously you will get a A1, right? So same thing. Okay, so this is for just understanding an example, but how this subnet mask will help you to do the thing. Here it is 190 dot 168 dot sorry, really class B or class C, which one is better? Let's take class C only. 190 dot 168 dot 20 dot 50. Okay, it's a very simple 50. This is the class C subnet mask. Class C subnet mask. 255 means what? 255 means 255 in binary. Sorry, the question is 255 in binary. 255 in binary. This is subnet mask. The first one is IP address. This is IP address, and this is the subnet mask. So I am using a default subnet mask. Okay. So 255, if you convert into binary, 8 ones. 255, 255, 255, 255. Right, it is wrong. 255, 255, 255. So like this. What about 0? 0 in the binary, you have to write 8 bit zeros. So totally, how many ones are there here? 24 ones are there. How many zeros? 8 zeros are there. So totally 32 bits. Okay. If you want to do ending operation, you want to do ending operation. So already I converted. This one is very easy, but this is very difficult to convert it, right? For everything, we can't able to convert 192. Again, conversion is difficult. But I'm doing that one. What is meant by subnet mask? Subnet mask will tell you what is your network ID. Subnet mask will tell you what is your network part and host part. So when every system has the IP address and the subnet mask, right? So I will show you that again. Last time I queried about IP address, how to check IP address, right? So this is my IP address and it contains a subnet mask. Based on this subnet mask, what network I am belongs to it and what network I can able to communicate. So we get to understand. Okay. So this is a 192, but 168 is different. So 1 means 128, 40, 40, 64, 32, 40 minus 32, 8. This is 168, I think so. Okay. 20, 20 is easy. So 0, 1, 1 means 16, 4, that is okay. Again 50. 50 means 0, 64, is binary equivalent. Maybe it can be there is a mistake, but it's not that one. If you want, you can convert each and everything into binary and verify my answer. Okay. So I convert my IP address into binary, and I convert my subnet mask into binary, and will do ANDing operation here. I'll do ANDing operation here. Okay. Now we see 1 1 0 0 0 0 0 0 like this, because 1 1 1 1 1 1 0 1 0 0 1 0, larger it will go on 1 1 0 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0 1 0 1 0, again 0 1 0 1 0 1 1 0 1 0 0 1 0 0 0 0, means 1 0 is also 0, right? So like that. So 0 0 0 0 0 1 0 0 0. So this is finally my network ID. This is my network ID. So I have to convert into decimal format 192.168.20.0. This is the equivalent one. So this is 192, so 168 and 20 and 0. Okay, so this is my network ID. So what I got here, network ID. Network ID will tell you which network you are belongs to. Are you belongs to this network or a different network? So this is how we can able to calculate. For the first time only, I convert everything into binary and I run an ANDing operation. For next time, I don't do it. I will follow 255 rule only, 0 rule. So when 255 is there, it repeats same. If 0 is there, whatever the number is here, it becomes 0 only. Okay, so like that you follow. So we see 172, 16, 34, 123. What is the subnet mask? Which class it is? Class B. What is subnet mask? 245, 245, 0.0. Now I want to calculate. Very good. I want to calculate network ID. Very simple. 172, 255. 255 means all are ones. Are ones only. So obviously I will get the same number. 16 to 55. 255 means all are ones. What are the equivalent of 16 is? We will get the 16 only. 34 0. Very good, Kavya. 34 0. So 0 means all are zeros, you will get 0 only. 123 0, you will get 0 only. So this is my network ID. Obviously, we will understand by looking at it, but how system is understanding like that. So, for example, this is my PC. For example, this is ECA. Sorry, PC1. PC1 IP address subnet mask. This is network ID. I have another PC, PC2. 170.16. 234 dot 253. See, this look like a very big number, right? So like same subnet mask, okay, because it's a divide or it is a class B. 172 255, we get 172. 16 255, 16. 234 0, you get a 0. Again, 253 0 0. This is my network ID. Now, can you tell me PC1 and PC2 can communicate each other? Both can communicate each other or not? It is a simple question. Okay. So, how both systems understand whether they can communicate each other or not? By their network ID is same. Their network ID is same, so then they can communicate each other. So then these systems understand both are same logical network. Same network ID means same logical network. I will tell you one simple example now. What is the effect of, yes sir, already we say in here network portion and host portion. We know whether they are communicate or not. By default, we are looking at which class of the IP address both are in the same class and check their network portions. So then we can understand whether they can able to communicate or not. Right? Generally, I'm repeating again. So earlier I given some examples whether these two pieces can communicate each other or not. Check their network ID. If network ID is different, they don't communicate each other. If network ID is the same, they can communicate each other. I given that statement. So that is like very pretty straightforward, right? Check the network ID, network portions. You can understand whether they can able to communicate or not. Right? Then what is the use of subnet mask? We are already known they can communicate each other or not. Okay, what is the use of subnet mask? You tell. You know how to eat your food and someone is giving a video like how to eat your food. What is the difference? It's like that one, right? People are now teaching everything, awareness, like me, okay? So why we need a subnet mask to tell both are in a same network? We know both are in same network, right? This network portion is same, so obviously both are in the same network. So then what is the use of this subnet mask? So one thing is subnet mask will derive network ID from your IP address and both network ID same, they will communicate each other. This is mechanism by system only, not by us. This is one reason. Second reason is we can change the subnet mask if you want it. If I change the subnet mask like this, what will happen? This is class B. Class B default subnet mask is this one. But if I use this is my subnet mask, so what will happen? 172 to 55, 172, 16 to 55, 16, 34 to 55. This is 34. 172 to 55 again, 16 to 55, 234 to 55. This is become 234. Now the network ID is different now. Earlier is we got the same network ID. Now I change my subnet mask in about the PCs. Now I got a different network IDs. It means these two pieces cannot communicate each other. These two pieces cannot communicate each other. By changing subnet mask, both are become different networks here. Just for example, for understanding what is the effect of subnet mask. If you change the subnet mask, obviously you may be in a different network. Network also will change. Network will be decided by subnet mask. The network ID is we get it from subnet mask. Okay, understand? got the point or not? This point. I know you understand this one already. Okay. Second one. In the second one, the second one, I change my subnet mask. Okay, see here it is default subnet mask is this one. I change my subnet mask here. Okay, so I change my subnet mask. Network ID become different. So here it is. Normally we think. So by looking at an IP address, we know the class. If you know the class, you know the network version, host version, right? By looking at the IP address, you know what class it is. Once you know what class it is, we know which one is network version and host version. So then we can understand both can communicate each other or not. Okay, both can communicate each other or not. We can understand, but system don't understand why like that. System understand why subnet mask. So the subnet mask will derive network ID from your IP address only. It will derive the network ID. If both of these are in the same network, they communicate each other. If both are not in the same logical network, if network ID is not same, they won't communicate each other. Simple. In a LAN network, very simple network like both network ID are same, they communicate each other. If network ID is different, they can't communicate each other. Okay, so who will tell the network ID? Subnet mask. If you use a subnet mask like a default subnet mask, okay, so that is on one hand normally. But if you change the subnet mask, the network ID will be changes. See here it is. Here is the network ID is like this. But if you see here, the network ID is different because of I changed my subnet mask. This is the main purpose of network. Then the question is why? The question is why we need to change subnet mask? Already it is there now. It is already there, right? It is already some subnet mask is there. Why we should change it to do it like this? So then there is a several reasons are there why we should change the subnet mask in a certain scenarios. We can able to do it. I will ask very simple question. Again, this is a subnet mask. Not IP address, guys. This is a subnet mask I'm typing. Okay, this is a simple subnet mask, like a classic based default subnet mask. So classic subnet mask, right? How many hosts we are getting? How many number of hosts we are getting here? 254. Here, how many hosts we are getting? 65,534 hosts we are getting. 16 million IP addresses we are getting from this one. But how we are getting? Because this represents network, this represents host. Number of zeros, 2 to the power of number of zeros in the subnet mask minus 2, it will tell how many number of hosts. But when I change here, when I change like this, what happens in this network? I am getting limited number of hosts only. I am getting limited number of hosts only. So whatever the class it is, the class is important, but keep aside of the class first. But look at your subnet mask. Your subnet depends upon your subnet mask, the number of hosts are changing. So here it is, if you look at here, okay, number of zeros are 8. Okay, this is the same thing, right? How many number of zeros? The number of zeros are 16 by default. So number of zeros are changing. So the value will change. The network size is also changes. More number of zeros, more number of hosts we can put it. Less number of zeros, less number of hosts you will get it. Very simple way. This is one explanation, but I'm not telling still why. The reason behind this change of subnet mask kind of stuff is, so I want to divide a network into small subnets. Subnet means small network. Okay, if I want to divide a network into subnets, I choose to change my subnet mask, then automatically network will divide. If I change my subnet mask, automatically network will be divided into small group of subnets. Second one is, we can assign a subnet to a network, means normal PC's network. So based on size of the network. Size of the network means number of hosts in the network. Number of hosts in the network, we'll divide the network and we'll assign that one only. Okay, we can assign a subnet to a network based on the size of the network. Meaning is, okay, we'll divide a network, same thing only, network based on number of hosts in that network. Okay, so we'll divide the network. So this is, we call it as a subnetting. This is, we call it as a subnetting. So why we changing the subnet mask? To do subnetting. What is subnetting? Is a very simple, divide a network into small subnets, means small networks. Small subnets are a small networks. Okay, small logical networks. Or assign a subnet to a network, means you are assigning a network to a network based on the network size, or divide a network based on number of hosts in the network. Again, still y is pending, right? So we'll see what is y. Again, we'll go to the y. I didn't tell you what is the public IP address and private IP addresses. I will tell definitely, but still it's okay. So we'll leave it. I don't want to mix one to another one. How many IP addresses? Approximately IPv4 4.3 billion IP addresses. Out of 4.3 billion IP addresses, class D, class E we are not using. So we are using from 0 is not useful, 1 to 223, right? So it means started with the one dot like this to 223. So 255. I'm writing total. This one, right? It is a class A starting. Of course, class A started with 0, that is reserved and we don't use it. We started with 1.0.0.0, 1.0.0.1. We'll keep going. And then class B, class C. Of course, 127 series we don't use it. 169 series we don't use it. When there is one series is there, we don't use it. But your total range, actual range is this one only. It means it is less than your 4.3 billion. It is less than 4.3 billion. Okay, so 256, this is 256 into 256, like 256 into 256 into 256 into 223, that is those many IP addresses we are getting. Okay, so if you have a calculator, even that is also wrong. Okay, so 256 into 256 So this is class B range, right? Again 256. This is this part. And 223 means actually it is 222, you have to put it, but I'm putting extra like 223. We'll see what will happen. This is 4.7. It means, sorry, 3.7, almost 3.7 million. Okay, it's around 3.6 billion IP addresses we are getting. Out of 4.3, 3.6 or 3.7 billion IP addresses we are getting. Originally we are using, because class D is not there, class C is not, we are not using. Okay. Now, in the world, how many systems are there, servers are there, websites are there, right? Websites are there. So, how many IP addresses are required into entire world, and is it enough? At least for current one, no problem for future. At least for current, 10 years back, 15 years back is also not enough. Okay, not only 2021, I'm talking about 2001. 20 years back also it is very difficult to manage, because that time only itself we have a lot of computer. 2000 time, almost 1999 I learned some computer thing. 2000 I know how to use internet. And outside, like, we have internet cafes are there. Some places there are charging very high, some places is a normal 20 rupees per hour, 25 rupees per hour, like that. Okay, so that time only computers are there, internet is there, network access is there. We learn those kind of stuff in my diploma, right? So is it enough IP addresses or not? So IP addresses are, it's difficult um, to get IP addresses. Managing IP address is very difficult, because it's a very less number of IP addresses. Another hand, so another important one is classes wise. It means, if I use a class, for example, of an already morning I told, right? So I have an office A. Okay, I have a around 100 computers are there, 100 PCs are there. Now I contact my service provider. I want 100 IP addresses. 100 computers means we need a 100 IP addresses. They cannot give 100 IP addresses. They will give one a class C network. Okay, they will give one class C network, because it will give you 100 IP addresses, right? They will give you a class C IP address. For example, they are giving like this 200.2.8.9.0. This is my network ID. So 0 to 255, 1 to 220, 254, I can use it. This is the network I got it. Now, how many IP address I am getting? 254. How many PCs are I have? How much is wastage? Okay, so almost 154 IPs we are not using, but I'm paying for 254, because they give, oh sorry, they are giving a network. So by default I'm getting 254, and I have only 100 computers, but I'm not using remaining 154 IP addresses. I'm not using remaining 154 IP addresses, but I'm paying for whole network. I have to pay. There is no chance, because they are giving one network. Second one is, if I don't use something, for example, I purchase all vegetable market, I went to vegetables, I pay 1,000 rupees. So one package is there. So 500 rupees, these vegetables. 1,000 rupees, these vegetables. Complete package is there. There is no selection of kilo per kilo, like in a Pune one is the example. You want to buy any leafy things, leafy curry things like coriander or anything you want to buy. So they will give 10 rupees, 20 rupees, like big bunch only there. The cost may be 10 rupees or 30 rupees. You have to pay for total bunch, whether you use it or not. So for me, an example, weekly I will throw a lot of leafy kind of stuff like this coriander kind of stuff. So why? Because it's so they're given a bunch, whether I take it for 10 rupees or 30 rupees, and it was wastage. If I don't use it, maybe it is useful for other organizations, right? Already we are in a shortage of IP addresses, and I'm paying for extra. If I'm a very big company, no problem, I will pay. I will waste, no problem. But if it's a small company, I can't pay. First thing. Second one is it is waste. Okay, waste of 154 IP addresses we are wasting. Okay. Next one, for example, if you take a class B, if you take a one network in a class B, example, 150.15.4.2, sorry, this is the network ID. So I am getting 65,534 IP addresses, but I have a PCs, my PCs are around 1,000 only. So I have only 1,000 PCs, but I am getting 65,000 PCs network ID. So how much wastage? I have 1,000. I got this network. My ISP provider give me 150.15.0.0 network. I got 65,534 host IDs, but I have 1,000 PCs only. Then how much wastage? 64,534 IPs are wasted. Guys, understand this example or not? Hello, guys, are you understand this one? Okay, Ganesh, very good. Okay, so wastage is become more. Now, so I call to my ISP provider. I call to my ISP provider. Then I ask like this, like I have 100 computers. Give me IP address, 100 IP addresses only. So they cannot do 100 IP addresses. They cannot give 100 IP addresses. They give network always. So what he will do, he take the network ID. For example, this is my network ID. They divide this network into small parts. They divide this network into small parts. Okay. I will show you one. I think I type wrongly here. Yeah, what happened? Okay, so I will divide this the network into small parts. Okay, so this is one network like that. So how to divide a network into small parts using change of subnet mask? Okay, so I have 100 computers only. I don't want 254 host IP addresses. So the IP we divide this network, the small subnets, and we'll give one subnet to computer. So we'll divide it and give it to this one by changing of subnet mask. If you change the subnet mask, obviously network size is also will be changes. Okay. So we'll see. I will tell you only this example how to divide a network into things. Very one example only I will tell. So then we will start understanding and calculating subnetting. Then I will show you only two things. One is IP address related, private IP, public IP, NAT/PAT kind of stuff. Today we are in IP address mode. So I will complete IP address related things only I will tell today. So tomorrow I will start with the basics. So actually I plan to start basics today, but tomorrow I will start basics only. And I will forward one more book is there. It is, you can see. So here is the definitions. I'll forward the definition, guys. Just read the one by one. If you don't understand, still no problem, but read it once. Okay, read it once. Different things are there. Why this is went up? Okay, different things are there. Just read it. Few things you can able to skip it. Few things just read it. You understand? No understand? That is the secondary part. At least see the diagrams. If you don't have at all time, so no problem. Just see the diagrams. Okay. So take a break. Take a 15 minutes break. Or you want 10 minutes only? 4:05 now. It is take a 4:15 means 4:20. Be there at by 4:20. Okay. I will start by 4:20. Okay. I'll start back at 4:20. Take a break. I'm going to pause the record first of all.
This conference is no longer being recorded.